In this lesson, we'll take an overview of the roll, pitch, and yaw control systems, then the flaps, and flight controls warning systems. We'll go into detail in later lessons. Primary flight controls on the Dash-8 are for roll control, the ailerons, assisted by geared tabs, and the spoilers. For pitch control, the elevators, and for yaw control, the two-section rudder. Secondary flight controls are the inboard and outboard flaps. As on the 100, the spoilers also act as ground spoilers to provide lift dump after touchdown. The ailerons are connected by cable to the right pilot's control wheel. The control wheels are interconnected, so rotating either control wheel deflects the ailerons in different directions. A manually engaged gust lock system, also known as a control lock, locks the ailerons in neutral. It is spring-loaded to the off position. Before engaging, move the control wheels to aileron neutral. In the on position, the ailerons are locked in the neutral position, and power levers can only be moved as far as the control lock. To unlock the gust lock, squeeze the trigger under the lever and pull the control lock aft. Hydraulically actuated inboard and outboard roll spoilers, operated from the left pilot's control wheel, increase roll movement. Normally retracted, they extend progressively with the up aileron, but above 170 knots, the outboard roll spoilers are inoperative. The roll spoilers automatically change from flight to ground mode after the aircraft has landed. The spoilers are all fully extended, dumping the lift and improving braking efficiency. Pitch control is by two mechanically controlled and hydraulically powered elevators, cable linked to fore and aft movement of the control columns. The left control column operates the left elevator, and the right operates the right elevator. However, the control columns are connected together, so moving either control column moves both elevators. 6 power control unit actuators are powered by hydraulic systems 1, 2, and 3. More about these later. The elevators are protected from gust damage by retained pressure in the elevator actuators. This gives a stiffness to the elevator. Control in the yaw axis is via both number 1 and number 2 hydraulic systems linked to PCUs on the fore section of the rudder. The trailing rudder is controlled by push rods from the fore rudder and deflects twice as far as the fore rudder. A summing unit takes input from either pilot's rudder pedals, from the yaw damper system, controlled by the autopilot, and from the rudder trim. It provides mechanical output to the two PCUs and artificial feel back to the pedals. A gust damper actuator protects the rudder from wind when the aircraft is parked. It has no effect when both hydraulic systems are pressurized, but when unpressurized, it restricts hydraulic flow between each side of the rudder, preventing slam movement. The inboard and outboard flaps are connected to jack screws operated by the primary drive shaft. The flap power unit is powered by the number 1 hydraulic system and controlled by the flap selector. The brains behind flight surface control is the Flight Control Electronic Control Unit, FCECU, located under the cabin floor. It receives signals and supplies outputs for all the primary and secondary flight control surfaces, as well as managing the flight controls warning and caution system. There are many controls and indicators associated with flight controls. For now, let's look at a few important ones. Flight control indications are on the permanent display area of the left pilot's MFD and the right pilot's MFD. The left pilot's MFD shows the position of roll spoilers, the left inboard and outboard, and the right inboard and outboard, the position of the left and right elevator, and the position of the forerudder. Note that the position of the ailerons is not shown. To the left of the right pilot's permanent display area is the flap position indicator. The glare shield powered flight control shutoff lights illuminate when there is a jam on the roll spoiler actuator control or in the rudder actuator summing unit. There are two disconnect handles used in the event of a jam in the roll and pitch control systems. Pulling and rotating the roll disconnect handle 90 degrees physically separates the two control wheels. After disconnection, the left pilot control wheel operates the roll spoilers and the right pilot wheel operates the ailerons. Similarly, pulling and rotating the pitch disconnect handle separates the left and right sides of the elevator control system. The stall protection system uses stick shakers to give tactile and oral warning of an impending stall. Two independent stall protection modules take input from angle of attack sensors and compensate for flap position, Mach number, engine torque, and icing status. They give early warning of a stall by shaking the control column. The rattling of the mechanism also causes a loud noise. Each stall protection module acts on its related stick shaker, causing its column to vibrate. But this vibration is also felt on the other column, because they are interconnected. The stick pusher system acts when the aircraft is in a stall condition to move the elevators and reduce the wing angle of attack. The takeoff warning horn sounds on the ground to alert you to a potentially dangerous takeoff condition. The horn can only be silenced by correcting the condition.